look at polynuclear aromatic hydrocarbons, known as PAH. Now, at the end of the session, you should be able to describe polyaromatic hydrocarbons. You should be able to draw structures for some polyaromatic hydrocarbons. And lastly, you should be able to state the sources of these polyaromatic hydrocarbons. So we will quickly, first of all, start with what polyaromatic hydrocarbons are. And these are fused systems that are formed when two aromatic groups are condensed, right? So they are also known as benzenoid aromatic hydrocarbons. The simplest of them all is naphthalene, which happens to be a product formed in the condensation reaction of two benzene rings. So the simplest you can ever think of is the fusion of two benzene rings to form naphthalene. So when three products or three benzene rings are fused together, then we can have two different products, right? We can have the linear formation leading to the formation of anthracene, or we can have the angular fusion leading to the formation of what? Phenanthrene. And I think we've looked about at this one. So we have three benzene groups being fused together to form polycyclic hydrocarbons, or you can have two forming polycyclic hydrocarbons. You can have 3, 4, you can have 5, you can have 6. And now the series of these linear polycyclic aromatic hydrocarbons are known as acenes, right? So please take note of that. And just as I said, the formation of, let's lose the laser. So the formation of three benzene rings being condensed can lead to either a straight, a linear product, or an angular product. So the angular fusion results in the formation of phenanthrene. This is phenanthrene. Now this phenanthrene again can further be condensed with another aromatic group, which can attack itself here or there or even here to form this product. So if it attaches itself into this side, it leads to the formation of a four-membered polycyclic aromatic hydrocarbon known as a pyrene. Now when this pyrene also is fused with another aromatic ring, which is a benzene ring, it leads to the formation of benzo-A-pyrene. So please take note of that. So we have pyrene, we have benzo-A-pyrene, or 3,4-benz-pyrene. So please let's take note of that. So all these tricyclic benzenoid compounds can further be annihilated to a variety of other benzenoid polycyclic aromatic hydrocarbons. So that's what we've been talking about. So this phenanthrene can be annihilated or condensed with other aromatic groups to produce other products, right? This pyrene as well can further be condensed or annihilated with another aromatic hydrocarbon, benzene ring, to produce 3,4-benzene-pyrene. Now, these polyaromatic hydrocarbons are nonpolar lipophilic compounds, which are byproducts of incomplete combustion processes. So please take note of the sources. We've talked about one source here, and they are commonly pollutants in air, water, and soil. Now, polyaromatic hydrocarbons are produced into the environment from a number of combustion sources, just as I talked about. Combustion, complete combustion lead to this. And these are some of the examples of the combustion process that lead to the production of these pollutants in air, water, and then the soil. So we have the exhaust of gasoline and diesel combustion engines. You have smoke from cigarettes. You have charred or burnt food. And then you also have the burning of wood or coal. And all these sources lead to the production of these polyaromatic hydrocarbons, which are also pollutants. So now, whenever we talk about pollutants, then we also look at the kind of health hazard they pose on the environment and human at large. So this slide will talk about the carcinogenic properties of some of these polyaromatic hydrocarbons. Now, most of them are believed to be cancer-producing agents, right? So it's kind of leads to some kind of heightened interest, which is being developed by scientists to research into them and find ways and means to reduce their production and how to solve issues that relate to their sicknesses. Now, 1,2 benz anthracene and its derivatives are very harmful carcinogens when it comes to polyaromatic hydrocarbons. So 1,2 benz anthracene together with its derivatives are very harmful and very carcinogenic when they are inhaled into the human body. Okay, so these are all other examples of these carcinogens. So these cancer causing agents, these are all examples of polyaromatic hydrocarbons with um, harmful carcinogenic properties, with benzo A pyrene, also known as 3,4 benzpyrene, being the most harmful